Hello everyone, and thank you for joining us today for the Introduction to M1. We're going to be going over the hardware, including our control panels, expanders, and accessories today. My name is Amy Strickland, and I'm with our Technical Support Department. Joining me today is Brad Weeks, who is the manager of our Tech Support Department. So we're glad to have Brad with us here today. Obviously, he's very knowledgeable, and he's going to be going over a lot of the M1 stuff with you today. Should you have questions while we're going through the presentation, we would definitely encourage you to ask those questions. There is a questions box in your GoToWebinar control panel on the right side of your screen. You can type those questions in there and we will get to as many of them as we can throughout the presentation. If there's a question that we can't answer, either because we run out of time or maybe your question requires more detail and we need to follow up with you, we will do that after the webinar. You are going to receive a follow-up email from us early next week, which will include a copy of the presentation that we're using today, as well as a recording of this webinar and some other links and documents and resources that we feel will be helpful to you. So before we get into what the M1 is, we just want to see how familiar you already are with it. So we're going to just launch a quick poll here. So if you could just take a moment and answer the question that you see on your screen. Going to leave this poll open for just a few more seconds. We really appreciate your participation here. Okay, so it looks like a great deal of our audience has never installed an M1 before and is not familiar with the M1. Although we do have some people with us who have installed a couple and even a couple of people who've installed several systems. So glad to have you all here with us today. We hope that there's something beneficial in this for you, especially for those who haven't worked with the M1 before. We definitely hope to send you away with some good information so that you're familiar and comfortable with the panel. Okay, well, if I can just, there we go. Sorry about that. All right, so we're going to talk about the cross-platform control. That's our M1 control, which is the security and automation control panel. It can do a lot of different things. You can kind of think of it as like a universal remote. You've got your security along with lighting control, energy management, access control, the ability to control any type of electrical devices, and that remote capability to be able to control that stuff from anywhere. So all of that entails what we refer to as our cross-platform control. And so here's, again, just an idea of some of the things that you can integrate in with the M1. The M1 itself is a rock-solid security system, but we can also integrate in a lot of different things using different technologies and other partner manufacturers to allow control of things like garage doors or gates, sprinklers. We have a water shutoff valve that you can use to, cut the water off if there's leaks, that sort of thing. We can control water heaters and small appliances, pumps, that sort of thing, lights and HVAC for energy management. So you can see it's just a total home or business control situation here. And even though we are showing a home, it's definitely something that you need to keep in mind as far as commercial applications are concerned, because there's a great deal of benefit with the M1 in commercial applications as well. Okay, so we offer two basic control options. We have the M1 Gold, which is what we'll be focusing on a lot today, but we do also offer the M1 Easy 8, which is kind of the little brother to the M1 Gold, so to speak. So there are some common features among the two different systems, and we have 6 different arming levels. Those are to allow you to activate all or parts of the system, just depending on whether you're going to be there or away, or if you're at home at night. You may want to have more of the house armed than you do when you're there during the day, but again, that would be different from your away mode where everything is going to be armed. So we've got all these different arming modes, and you can customize the system so that you only have access to the arming modes that you're going to use. So you can simplify things. If you don't need to use all 6, you can program it in such a way that it gives you what you need so that you can customize that for your customer. So we also support 199 users, a user being either an arm-disarm code or an access credential, whether that be a card or a fob, or an access code, or even a biometric device could be learned into the system as a user, with each individual fingerprint, so to speak, being a user. Both systems support up to 8 areas, have a 512 event history log, and have a built-in astronomical clock so that we know when sunrise and sunset occur. So if you drill down into the differences between the system, you can see that the M1 Easy 8 is a smaller system, with the M1 Gold being 16 on board, the Easy 8 being 8 on board. Both support the same number of wireless zones, and of course with the M1 Gold having 16 on board, it's capable of expanding all the way up to 208, where the Easy 8 only having 8 on board goes up to 200. The Easy 8 does not have voice features, so the M1 Gold can make on-site announcements, and give you a telephone call with a voice message for certain events, and it also has a telephone remote control. Those features are not included in the Easy 8, and they cannot be added to it. So the Easy 8 does not have that voice output. It has one less output than the M1 Gold, but again is very expandable on both systems. With the M1 Gold, you do have the option for two-way listening for alarm verification. That option is not available on the Easy 8. So those are just some key differences there. Okay, so with the M1 Gold or the Easy 8, there are a number of different keypad options that you can use, and you can use any of the keypads that you see on the screen here with either system. Each system can support up to 16 keypads, and you can mix and match models. So if there's a preference to have maybe the nice navigator, small discrete touchscreen keypad in a kitchen, but maybe you want a larger keypad in the master bedroom, you can certainly mix and match there. We've provided a comparison chart, and I'm not going to go over every aspect of this, but you will be getting this presentation in the follow-up. So you just have this information here. I'm pointing out some of the differences between the keypads. They're different physical sizes, have different backlight colors, and different features as far as supporting proximity readers or 26-bit Wiegand devices, number of F keys, that sort of thing. But you'll have that information available to you in the presentation that we provide in the follow-up. We do have a number of different remote control options for the M1. So we offer a piece of software called M1 To Go, which is a free Windows-based application that you can run on your computer or your laptop or your Windows-based tablet. We also have options available for the iOS platform. For your iPhone or your iPad, that's going to be eKeypad. For your Android devices, you're going to use M1 Touch Pro. And we also have cloud-based services available through Connect One, which is through our partner Connected Technologies, and that is a service that they offer. They have a lot of different options, and there are monthly fees involved in those cloud-based services. The other things, the M1 To Go, eKeypad, and M1 Touch Pro do not require monthly fees. eKeypad and M1 Touch Pro can be purchased from the respective marketplace for that platform. Now, as I was saying earlier, the M1, you can kind of think of that as your universal remote, and so we have a lot of different partner manufacturers that we work with so that we can do different things with our system and integrate in different aspects into the M1 system. So you can see here just some of the partners that we have. We have a detailed listing of our partners on our website, so if you want to check that out, you can go to elkproducts.com and you'll find a link to our partner manufacturers, our integration partners, and that will tell you all the things that you might need to know, what the partner does, how we integrate with them, that sort of thing. But this is how the M1 can encompass so much by being very integration friendly and playing well with others. All right, for system layout and expansion overview, I'm going to turn it over to Brad.
All right, thank you, Amy. Once again, we greatly appreciate everyone's time today and joining us in our webinar. Right now, we're going to go over a little bit of system layout and expansion overview, some wiring and installation tips. At any time, if anyone has a question, please feel free to type that into the box. We'll try to get to as many of those as possible. And hopefully by the end of the day's webinar, you don't feel quite like this guy here at the bottom of the screen. All right, so what we're looking at right now is the M1 Gold main control, the terminal overview. As you can see on the left-hand side of the board, we have our on-board zones. We have our AC input and our auxiliary DC voltage outputs. We have our master on-off switch in the lower left-hand corner. We have our battery leads. And at the bottom of the black plastic housing, there's a white barcode sticker that has the M1 serial number. This is a unique 8-digit number. There's never been 2 serial numbers duplicated. And this will be very important when setting up your account in the RP software. In the upper right-hand corner of the board, we have our terminal block for our telephone connection. Below this, we have the M1's RS-232 serial port. In the middle of the right-hand side, we have our low voltage outputs, and we have outputs 1, 2, and 3. In the very lower right-hand corner, we have the M1's RS-485 data bus connection, and we're going to go over some of these connection points as we go through the webinar today. All right, starting with zone input connections, the M1 main control, each zone can be configured with the end-of-line supervised resistor, which is a 2.2 k ohm resistor, or they can be configured normally open, normally closed. This is by zone. It's configurable through keypad programming or through the Elk RP software. If you are using the 2.2 k ohm resistor, it's really recommended that the resistor be placed at the very end of the loop for proper supervision. Each zone shares a negative with the zone beside it. So as you can see in our block diagram here, we have zone 1, negative, zone 2, and then zone 3, negative, zone 4. So every zone, or 2 zones, share the same negative connection. The system does support 2-wire smoke detectors, and zone 16 is the only zone that will support 2-wire smokes. The JP1 jumper located at the bottom of zone 16 can either be set to 2-wire smoke or normal zone depending on what you're connecting. If you're connecting a 2-wire smoke detector, you want to make sure the JP1 jumper is on the right 2 pins. And because we're using 2-wire, you must use the 820 ohm end-of-line resistor at the last device. Now, it is possible to connect up to 20 detectors in a daisy chain configuration to zone 16, but we really highly recommend you use the same make and model. And if you take a look at page 6 of the M1 installation manual, there is a compatibility chart that shows you which 2-wire smokes are compatible with the M1 system. If the 2-wire smoke isn't listed, then we recommend you not use it with the M1 system. Another feature of the main board would be the ability to use temperature sensors. The temperature sensors monitor the ambient temperature around the sensor. The housing for the sensor is not weatherproof or waterproof, so the housing interface should be mounted indoors. But the temperature sensors allow you to show, say for instance with the probe there, you can show the outdoor temperature on a keypad, or you can use the sensors to monitor, say, server rooms, wine cellars, attics, crawl spaces, or just the ambient temperature in an unoccupied area. You can use rules based upon the temperature settings to do different events, to turn on relays, turn on fans, call somebody, send a text message, and so forth, once the temperature reaches either above or below a set point within your rule. Now on the right-hand side we have the M1ZTSR. The R stands for remote probe. This is a 7-foot probe, and that can go into a harsher environment like into a freezer or a cooler or outdoors. The probe is not waterproof, so it should never be submerged into liquid. The temperature sensors allow you to monitor temperature from -50 degrees Fahrenheit to 120 degrees Fahrenheit. And once again, these sensors connect to the main board only, so you can have up to 16 of them connected to the M1 system. Now besides the on-board 16 zones, the system is expandable using hardwired zone input expanders. These are the ELK M1XIN, and they're in 16 zone increment. The dip switches on the input expander will determine the starting address or the starting zone number, and you can have up to 12 expanders on the data bus. Now the M1 system is flexible as far as 4-wire smoke detectors. Any zone on the system, including input expanders, will accept a 4-wire smoke detector. Now for a wireless solution, ELK offers the ELK TwoWay wireless products. If you notice here, the first item in the list is the ELK M1XRFTW. That's our wireless transceiver. And we call it a wireless transceiver because it'll actually send and receive wireless signals from the devices. You might think, why is that important? Well, for instance, let's take our 6050 smoke detector. This is a wireless smoke detector that has a built-in sounder. If this detector detects smoke, it'll send the signal to the control, but it'll also start its internal sounder. Well, when the M1 receives this signal, it turns around and sends a signal out to all the other wireless smoke detectors, so they all start sounding at one time. This is a great feature and doesn't require any additional hardware, such as with hardwired smoke detectors, you would need a reversing relay module for this feature. With the ELK wireless smoke detectors, it's built in for you. Each sensor that we offer, our glass break, our motion, window door sensors, and so forth, all have a built-in LED to let you know when the signal is received and acknowledged. So for instance, on our 4-button key fob, for instance, it has an LED at the top, and we have the number 3 button, or we call it the inquiry button. If you press this button and the LED lights up green, system's disarmed. If it lights up red, system's armed. If it happens to flash red, it means the system has been in alarm. So it's a great indication before you enter your home to let you know if the system is armed or if it's been an alarm. Now on our window door sensors, our 6020, 6021, or the 6022, the LED will light green if it gets the acknowledgement back from the wireless transceiver that the signal was received. If it lights up red, signal was not received. So it's a great troubleshooting tool also to let you know if you're in or out of range of the wireless transceiver. If you have a large area you need to cover using wireless sensors, you can add additional wireless transceivers to the data bus to help increase the coverage area or to eliminate any dead spots that you might have. You can have up to 4 ELK wireless transceivers on the M1 data bus. Now this gives you, the M1 will support up to 144 wireless zones. Out of the total 208, 144 of those can be wireless. A nice feature of the ELK 6022 universal 3-zone sensor, not only does it have a built-in reed switch, it also has 2 hardwired inputs as well. You can use all 3 of them at one time from the one wireless sensor. The ELK 6030 motion detector, which is also available in a pet immune, the ELK 6030P, has a built-in courtesy LED that you can control to help light the way during darkness or when the system goes into alarm. You can control it using the ELK RP rule engine and rules to turn on and off the LED built into the 6030.
We just wanted to add to that, we will be releasing a recessed door contact in our two-way wireless line soon. I don't have an exact date, but just be on the lookout for that. That's coming out pretty soon.
Absolutely. Thank you, Amy. Greatly appreciate that. That is true. Yes, the new recess sensor should really round out the ELK two-way wireless family. Other options for wireless include the ELK M1X RF2H wireless receiver, which will support the Honeywell 5800 series wireless, and the ELK M1X RF-EG receiver, which will support the GE wireless sensors. So you could actually mix all 3 technologies into one system, and it'll work just fine. But you would need one receiver to support each wireless device. So if you're using GE wireless, you would need the EG receiver. If you had Honeywell wireless, the 2H. And then if you wanted to add ELK, you would need our M1X RF TW receiver. Once again, we support up to 144 wireless zones. Now, one receiver by itself will handle 144 wireless zones, but if you have a large coverage area, you may need to add additional receivers to help increase the coverage area or eliminate any dead spots or weak signal strength areas. All right, taking a look at the left-hand side, lower left-hand corner of the M1 control board, we have our power connections. Now we have the S-aux terminals, which are 12-volt DC switched terminal, and typically that would be used in conjunction with devices that require their power to be removed in order to reset them or unlatch their contact. Say, for instance, 4-wire smoke detectors. You would connect the power for the 4-wire smoke detector to the S-aux terminal, and then the contact to a zone on the main control or an input expander. And then in the event that the detector goes into alarm, its contact latches. You can either from the keypad or from the rules activate the system to remove power from the S-aux terminal, which will power down the device and cause it to reset. Below this is the V-aux terminals. These are terminals normally, they're not switched, they're constantly on, and they provide 12-volt DC for your glass breaks or your motions or any other device which may need constant power. We actually give you 3 terminals here so to help divide up the load, so to speak, to help share the connection point so you're not trying to land all of these wires under 2 screw terminals. We actually give you 3 terminal places to power your motions and glass breaks and so forth. The AC terminal input is for your low voltage step-down transformer, the ELK TRG 1640, which is included in the kit, and this supplies AC power to the M1 control. Below the AC terminal input is the master on-off switch, and this is a convenient way to cut off both the AC and the battery to the control for service or updating or so forth, or if you just need to power down the system for whatever reason, you simply move the on-off switch into the off position, and there's no need to disconnect any transformers or remove any battery wires at this point. The battery connections on the M1 will support up to an 18 amp hour sealed lead-acid battery. Now what if we need more power? Well, ELK offers the ELK P212S remote power supply. This particular, it's a 2 amp power supply. It also provides battery backup. You can use it in a standalone as just a simple 12 volt DC 2 amp power supply, or it can be a supervised power supply over the M1's data bus. It can be remote located, and it's perfect for large installations where you're going to need additional power out in the field. It has a programmable output, and it's controlled using the M1 rules. Now, it does require its own transformer, which is sold separately. All right, in the very upper right-hand corner of the M1 board is your telephone line connection. And this is normally used just connected to an RJ31X. And it's very important to make sure that the incoming phone line connects to the M1 first before it connects to the house phones downstream for proper line seizure and for reporting alarms and events. Now, because the automation features of the M1 is always connected to the telephone line, and ELK strongly recommends that you use a telephone line surge suppressor such as the ELK 952 connected to the board. And below this is a block diagram on how to connect the incoming telco line to the RJ31X, then to the house phones, and then incorporate an ELK 952 into the control. A feature of the M1 system is its two-way listening capability, and this would normally be used for central station verification on alarms to help avoid those unnecessary dispatch of authorities when it's just somebody accidentally burned a toast or something. But it also allows for individuals to call into their system and listen in to maybe perhaps check on a loved one, or for whatever reason they need to listen in to make sure dog's not tearing up the furniture or whatnot. We offer two interface boards, the ELK M1 TWA and the ELK M1 TWI. The TWI is just a standard interface that allows you to connect the microphones up to the M1 system. You can have 3 zones of microphones and a total of 12 microphones connected to the system. The M1 TWA is a little bit different. It's still part of the two-way listen-in interface, but it also has the capability you can connect your speakers to the M1 TWA, and you have 3 zones of individual volume control. You also have the capability of being able to mute certain speakers using the rule engine. This is a great idea if you have a multi-level home, for instance, and the upper level may be the sleeping area, and you want to mute those speakers during certain hours of the day. If the baby's sleeping or somebody who works evenings or whatnot may be sleeping, you don't want the normal spoken activity of the M1 system to disturb them. So you can mute certain zones of speakers. Now when the system goes into alarm, all of this is overwritten automatically, so if there's an alarm condition, all the speakers would start enunciating the voice description as well as the siren sound. On the right-hand side of our slide right now, we have some examples of our two-way listen-in speaker microphone combinations. We have a surface mount and a flush mount, and then we offer just the microphone only. Now, besides being able to communicate over a landline to your monitoring service, there's also the capability of cellular communication using the Uplink 4500EZ. Now, the Uplink 4500EZ connects to the M1 system using our M1XSP, our serial port expander, which has special firmware update to support the Uplink and the AES IntelliNet radio. And this gives you full contact ID reporting through their proprietary network and then transferred to your central monitoring service. On the market today, there are a number of dial capture devices from companies such as Uplink and Telguard and others, which simulate phone line voltage and current so that the security system doesn't know it's not connected to a landline. And when system goes into alarm, these devices will capture that data and then relay it through their network to your central monitoring station. We also have the capability of IP alarm monitoring over the Internet, which requires the M1XEP Ethernet interface. At this time, the M1 is compatible with the DSC SureGuard 3 and the Osborne-Hoffman 2000E central station receivers. Sorry. All right, right below the telephone connection on the M1 is the M1's main serial port. We call it serial port 0. This is used for programming the M1 using the ELK RP2 software or interfacing with some third-party software or other hardware. You can do a direct serial connection using a standard RS-232 serial cable or a USB to serial adapter. You also have the capability of being able to connect the XEP module to serial port 0, which would allow you to access the system over the local area network or remotely. It also allows for the third-party apps such as the iPhone and Droid app and the M1 to go to connect to the system remotely as well. Now, speaking of the XEP interface, like I said, this is used to connect the M1 to the local area network for programming as far as the RP software. It also allows for third-party software and hardware to communicate over the local area network to the M1. It is a secure connection, so for Internet access, it's encrypted connection. It allows for email and text notification, IP monitoring. We also support updating using a dynamic DNS provider. And we have a feature to allow you to sync with a national time server so that we always make sure that the M1 is up to date as far as time and date. Now, the outputs on the board, we have output 1. Typically, this is for your voice and siren output, which is normally used with interior speakers, speakers only, and make sure that you keep the overall speaker load between 4 and 16 ohms. You can do this by using a series parallel combination of speakers, just making sure you keep the overall load above 4. Output 2 is a supervised output on the board, and it can be configured to use a built-in siren driver, no voice capability, just the siren driver, in which case you could use regular speakers, once again keeping the overall load above 4 ohms, or you can configure output 2 to be a voltage output. When set to a voltage output, it's 12 volt DC at 1 amp, and you can use that to control self-contained sirens or a strobe or some other 12 volt DC device that doesn't draw more than 1 amp. If you do not plan on using output 2, it is a supervised output. It's expecting to see a load. So if you're not using it, install a 2.2 k ohm resistor across output 2 positive and negative to avoid the output 2 trouble condition. Make sure it's a resistor and not a dead short. Output 3 is a general purpose Form C relay. It's programmed using the ELK RP rule engine, and you can use it to control other 12-volt DC devices, maybe from a secondary power supply. It's 12-volt DC rated at 4 amps. Outputs 7 through 16, those are our low voltage outputs, and they are right here in the upper. We provide you with the flying lead wiring harness. Those are 12-volt DC at 50 milliamps each, switched positive. You can use this to control LEDs for remote visual indication of the status of the system, or you can use it to control other general purpose relays. Like I said, it's 12-volt DC at 50 milliamps each, and they are programmable using the ELK RP rules. We offer the ELK M1RB board, which connects to J16 there, and that'll convert outputs 9 through 16 into Form C relays. Now, if you need additional relays or outputs, we offer an output expansion board, the ELK M1X-OVR, and that can be used to control garage doors or sprinklers or pumps. These outputs are rated for up to 120 volt AC at approximately 8 amps. Now, on the M1X-OVR, you have 8 physical general purpose Form C relays and then 8 low voltage outputs. It is possible to add an M1RB to the XOVR, and that'll convert those 8 low voltage outputs into 8 physical relays. So now with a combination of these two boards, you have 16 physical Form C relays to switch whatever you need to switch. The dip switches on the XOVR determines the starting output number of your relay. And you can add additional XOVRs to the data bus, and you can even remote locate them if you need something, say sprinkler control. It'd be more convenient to have the XOVR out in the garage where the solenoids are versus at the control. The XOVR can reside on the M1 data bus. Now, speaking of the data bus connections, I'm going to turn it back over to Amy, and she's going to go over some data bus connections.
Thank you, Brad. Before we go over the M1 data bus, I do want to address some questions that have come in. So we had some questions about the wireless receivers that we talked about, and mixing and matching and that sort of thing. So I'm just going to provide some clarification on that. The M1 XRF-TW supports the ELK two-way wireless sensors. The M1 XRF2H supports Honeywell sensors, and the M1 XRF-EG supports GE sensors. So you have to have the receiver that supports the sensors that you want to work with. It is possible to have a mix and match wireless on the system, granted that you have the proper wireless receivers or transceivers to support the sensors that you're using, and that device, that transceiver or receiver has to be within range of the devices that you're wanting it to be able to communicate with. And what I mean by that is, the 2H receiver cannot get signals from ELK transmitters. It can only get signals from Honeywell transmitters, and vice versa. So you have to make sure that you are within range. But keeping that in mind, it is possible to have multiple kinds of wireless on one system, and that does work just fine. Regarding the M1XEP, it is possible to set a static IP address on that device on the local network so that you can have port forwarding to do the remote access and that sort of thing. If you're interested in using the M1XEP, we have done a number of different training webinars and different things on that XEP, so I would encourage you to go check out our YouTube channel. There's some great resources for you there if you want to learn more about the Ethernet interface and its features and how it's set up and all of that. It does allow for remote connections from a number of third-party devices like the apps that we've talked about today, as well as some other things. There is a secure encrypted port on the Ethernet interface for those remote connections, but there's also an unencrypted port available for local connections for different things like maybe Control 4, Crestron, those kinds of things that you might want to integrate with. Thanks for all those questions. Keep them coming. We're going to go ahead now and dive into the data bus. This is, by far one of the more confusing things, especially if you're not familiar with the ELK system. So we want to go into this and, really try to help you, clear the muddy waters on how the data bus works. So the data bus is for connecting a number of different devices. Obviously keypads is one of the first things that come to mind, but a lot of the devices that Brad just went over connects to the data bus, like input expanders, output expanders, the wireless receivers. We have serial port expanders for integrating with things like thermostats and different lighting systems. The supervised power supply that Brad was talking about, when it's supervised, it connects to the data bus. We have access modules and just a number of different things that you can connect to the M1 over the data bus. Now, that being said, all those different possibilities and devices, you can't have more than 2 runs coming directly into the M1. Now, that's not to say that you can't have more than 2 devices coming directly into the M1. You can have daisy chain connections of devices where you're going from the control to a keypad, and then say from a keypad to an input expander, and from that input expander to something else on down the line. You can continue through that, and you would terminate the device at the end. So you could have 2 runs like that, and you can see kind of an example of that in the diagram below, where we have 2 runs, 4 devices, and the 2 devices at the end of the run get terminated. Now, what I mean by terminated, each device that we can connect to the data bus has a jumper to allow it to be terminated if it's the device that's at the end of the run and it needs it. So when we refer to termination, it's simply installing a shunt on a jumper, and each device has one. So that's a pretty straightforward, easy thing to do if you know where to put it. And so we're going to help clear that up for you if you may be confused about that. The data bus wire length cannot exceed 4,000 feet. So that's for the entire bus. So you have to do that calculation of how far each run of wire is taking you, and make sure that that does not exceed 2,000 feet. So that being said, you can see in some installations it may be hard to meet some of the requirements, specifically, the more than 2 runs. So we've thought about that and how we can help you out to make that easier for you. And so we have data bus hubs. And what the data bus hubs do is allow you just to home run devices directly to the hub, and then the hub connects to the control, and it eliminates this concern about how many runs you have going to the control. So we offer 2 different kinds of hubs. The first hub is for new installations, where we recommend using either Cat5e or Cat6 wiring. So you're going to have an RJ45 termination on one end, and on the other end you'll have it wired to the device. And so all the devices home run to the hub, you do your RJ45 termination, plug it in, and go. This device also simplifies your termination of the data bus in that we provide this small little plug. It's an RJ45 plug with a resistor in it. And I would caution you, if you're going to use this hub, to definitely check your hardware packs and not throw that away, because you do need it. But the terminating resistor is in a plug, so you just plug in all your devices, and the next empty port that's available, you stick your terminating plug in, you're done with termination. You don't have to worry about terminating any of the devices with the jumpers on the device. Now, this is a passive hub. It's just making connections internally, looping the data in and out, and the way that it does that, the data goes out to the device and then comes back to the hub. So when you're doing the calculation for your total wire length of 4,000 feet that I was mentioning before, you have to calculate the runs for the M1 DBH as double. They have to be counted as round trip, there and back. So that's something to keep in mind, that can effectively cut in half that 4,000 feet. So that's just something to be aware of. But that's the hub we recommend for new installations. Now, we realize that the M1 may be replacing an older panel where you already have existing 4-conductor wiring, so we offer a hub to support that as well. That's the M1 DBHR, which is considered for retrofit installations. It's an active hub, and so it takes the M1 data bus and kind of just branches it out into 4 little mini data buses, so to speak. And those, each branch, each little mini data bus has the same rules as the big data bus, as far as the number of runs that you can have cannot exceed 2, and it always has to have 2 termination points per branch. So those are some things to keep in mind with that. Now, the hub for new installations, because it's just a passive hub and it's just making connections, it can actually be remotely located from the control. So this is good if you have a longer run. You need to have several devices at a remote location, maybe on the other end of the building or something like that. You can drop a run from the data bus out to this hub, and then run all your devices to the hub and have it there remotely. But with the retrofit hub, because of the way that it works with all of its active circuitry, you can't do that. It cannot be remotely located. It needs to be right there in the enclosure with the M1, very, very close to the M1. So 2 different hubs for 2 different situations or scenarios, but it's good to be familiar with both, and you'll find that in different situations one hub works better than the other. But again, just keep in mind the retrofit hub cannot be remotely located from the control. Okay, so diving in just a little bit more into the hub for new installations, the RJ45 style hub. We talked about, you just home run your Cat 5 or Cat 6 cable back to the hub, terminate with an RJ45 plug, and you're done. So this is going to show you how to wire it up at the other end. So we have an example here of a keypad. So you're going to be coming off of the keypad harness where you're going to have a red, black, green, and white wire. This is equivalent if you're looking at an input expander or an output expander or a device that has screw terminals instead of a wiring harness. Those terminals are labeled 12 volt, A for data, which is the green wire, B data is the white wire, and then you've got your black as your negative. So the wiring is the same whether it's a keypad like you see here or again a device with screw terminals. So you're using 6 of the 8 conductors in your Cat 5 or your Cat 6 cable. Your brown is going to be your positive 12 volts, white brown would be your negative, and then you'll notice there on your data A, which is the green here, we have the orange and green connected to it. Your data B, which is the white, has white orange and white green. So you have to have those 2 conductors from the Cat 5 per data line, and that again is what allows that return path. Okay, so maybe we've blown your mind, and maybe that all of that just makes sense, but we're going to go through some examples here. So Brad's going to help us out with some pop quizzes.
All right, so in this example here, where should the data bus be terminated? All right, and if you answered A and C, you're correct. That's because we have a single run, daisy chaining 2 devices together, and in this case, the JP3 jumper on the main control would accept the terminating jumper, and the last device in the loop would have a terminating jumper. Hope everyone was paying attention, because we've got another pop quiz. In this example, where should the data bus be terminated? All right, if you answered C and F, you'd be correct. This is 2 home runs coming off the control, and we have devices daisy chained together. So the keypad would accept the terminating jumper, and the last device here could be an input expander, could be an output expander, would be terminated as well. All right, we're going to make it a little tougher this time. This is using the M1 DBH, so take a few minutes, look at this, and let's decide where the terminating jumper should be installed. All right, the correct answer would be A and G. In this case, we have the data bus hub, and there's just a single run going to the data bus hub. So JP3 on the main board would be terminated, and then we have 5 devices connected to the hub. So the first unused port of the hub, you would insert the terminating plug. So in this case, the answer was A and G. All right. Now we've got the M1 DBHR. This is the retrofit hub. A little bit different, so take a few seconds here, and let's see how well you do. All right, here's the answers to our pop quiz. And in this case, the retrofit hub is located at the control itself, very close to the control, the shortest wire run from the control to the retrofit hub. It's a single run going to the retrofit hub, so JP3 on the main control will be terminated. And because the retrofit hub is the only device that's connected to the hub, the JP1 jumper on the retrofit hub would be terminated as well. Now, each branch on the retrofit hub is its own little 485 data bus. And in this case, branch 1, we have a single home run coming off the data bus, and we've daisy-chained 2 keypads together. That last keypad will have the terminating jumper installed, and on the retrofit hub, JP2 would be installed as well. On branch 2, we have 2 home runs coming off the branch, one going to a keypad, one going to some sort of output expander or input expander. And because we have the 2 home runs, each device will have a terminating jumper, but not the retrofit hub. For branch 3, once again, 2 home runs, one going to a single device, one going to 2 devices daisy-chained together, and in this case, each device on the end of the run will have a terminating jumper installed. On branch 4, we have just a single home run coming off the branch to a device. The device gets terminated, and the retrofit hub gets terminated. So if you got all those, very good.
So let's just review a couple of important points about the data bus. You cannot have more than 2 runs going into the data bus, and it is always looking for 2 termination points. So in a number of our examples, you saw the use of the JP3 jumper to provide the second termination point when there was a single run to the control. With the retrofit hub, each branch is like a little mini data bus, so it follows those same rules where you cannot have more than 2 runs, and it's always looking for 2 termination points, and so that's why it has so many jumpers. But if you have more questions about that, or if you're during an installation you're just not sure whether or not you have the termination correct, we're always here in tech support to help you with that sort of thing, so just reach out to us and we'll be happy to help clarify those issues for you if you have some confusion about the data bus. So next week, next Friday, which is the 17th, we're going to be doing part 2 of our M1 introduction training, and this training next week is going to focus on programming with ELK-RP. So we went over all the hardware today and tried to familiarize you with the features and the different things that you can do with the system. Next week we're going to show you how to program that all with our programming software ELK-RP, which is a really great application for programming the system system. And while you can do quite a bit of programming related to the security functions of the system from the keypad, you can do everything from ELK-RP, and it just makes it so much easier. So we really hope that you'll join us for that. We will be sending a link to register for that webinar in the follow-up email, or you can just hop on our website and you know, there's a link there as well where you can sign up. So we do have a couple of questions here. Total length of each retrofit board RS-45 connection. Okay, so I think what we're asking here is how far you can come from each branch. And again, this is where you want to keep that 4,000 feet total in your mind for the entire data bus. You just want to definitely follow that. So okay. There is a question here about the water shutoff valve that we're going to go ahead and address that afterwards. I had a question about the wiring scheme for the RJ45 on the data bus hub. We do use or recommend the use of the 568A wiring scheme. I suppose you could use the B wiring scheme, but you may have to wire the device differently, so I would recommend just following along with that diagram that I showed you before. That's just going to make life a lot easier for you if you just do it that way. That's the way that we would prefer you do it. We are going to launch a very quick survey at the end of this webinar. It's just a couple of questions. It shouldn't take much time out of your day, and we would appreciate it if you do have the time to go ahead and complete that so that we can get a little bit of feedback from you on how the webinar went for you today. And we are going to select one random survey participant to win an ELK t-shirt and hat. So again, if you have just a moment after the webinar, we would appreciate your feedback. We thank you very much for spending some time with us today. We hope you'll join us again next week for the second part of our basic training for M1, where we're going to go over the ELK-RP software. I want to thank Brad for being with us here today and doing such a great job teaching us all about M1, and I hope everyone has a great weekend.
Thank you, Amy, and thank you everyone for participating. We look forward to speaking to you soon.